On to the third test. Question number 1 asks, the average annual salary for someone with a math degree is $63,000, while it's $36,000 for someone without a math degree. How much more will someone with a math degree make over 40 years? So the first thing we need to do to figure this out is figure out how much more someone with a math degree will make over a year. So you can do that by subtracting $63,000 and $36,000, and you get $27,000. So every year, someone with a math degree makes $27,000 more than someone without a math degree. Then all we need to do is multiply that by how many years you'll do that for. In this case, 40. So you can take 27,000 times 40, and you get $1,080,000. And that's your answer. Question number 2. The formula F equals 1.8C plus 32 converts Celsius to Fahrenheit. If water boils at 100 degrees Celsius, what is it in Fahrenheit? So let's take that equation, and then we know what C is. C is 100 degrees. So all we need to do is plug in 100 wherever we see a C. So we get 1.8 times 100 plus 32. If you do all that work, you get 212. And that's your answer, 212 degrees Fahrenheit. This is a really important question that we're going to start using a lot. So expect to see this on future tests, where you have a formula that has multiple variables and you have answers for some of the variables, and that's going to require you to figure out what the answer is for the other variables. So in this case, we knew what C was and we had to figure out F. So expect to see more like this in the future. Question number 3. I paid $400 for a PlayStation 4 and $360 for a virtual reality set with my credit card, which charges 20% interest. If I don't make a payment, how much will I owe after 10 years? So hopefully this looks like a compound interest problem just in reverse. Instead of investing money, you're borrowing money. But the math is all the same. So the first thing we need to do is figure out how much I spent. I spent $400 and $360, so I spent a total of $760. Now remember, I'm being charged 20% interest a year. So what is the interest on that? It's $760 times 20%. This should start to look familiar. The interest on that is $152 in the first year. So after 1 year, I would owe the $760 plus $152. That's $912. And again, this is very similar to some of the compound interest problems we've done before. You can do that in just one step by saying 760 times 1.2 equals 912. You get the answer you got after 1 year. Do the same thing after 2 years. 912 times 1.2 is 1094. After 3 years, after 4 years, and on and on and on. And you could do that, if you did that 10 times, you would get $4,706. Which is the same thing as taking 760 and multiplying it by 1.2 and doing that 10 times. But as we said before, there is a button on your calculator that does this exact thing, and it's the x to the y button. So you can take 1.2 x to the y 10, and it multiplies 1.2 by itself 10 times. You could take that 1.2 x to the y 10 and multiply it by 760, and you get your 4706. So this is just like a compound interest problem, but just in reverse, where instead of lending money, you're borrowing money. Just as an aside, this is actually what credit cards charge, what many of them charge. And hopefully it strikes you as insane that after 10 years, you would owe $4,700 on something that originally cost you less than $800. Credit card debt is absolute cancer to your finances. And I really encourage all of you as you grow up never to get into credit card debt. It's just bad news. Question number 4, we are going to Las Vegas. If you play blackjack, you have a 48% chance of winning. So if you bet $1 each time, where if you win $1, if you lose $1. If you bet $1 each time, how much would you expect to win or lose after 100 games? So first, let's think about probability. Probability is 48%, and you can also write that as 0.48. We'll actually use the 0.48 when we use our calculator. So now we need to ask ourselves, how many times did we win? If we played 100 times and we had a 48% chance of winning, you could take 100 times 0.48, and that would give you 48. So if we played 100 times, we would expect to win 48 times. And if we won 48 times, that meant we lost 52 times. Now let's figure out how much money we won or lost. If we won 48 times, we would win $1 48 times. That means we would win $48. But remember, we lost 52 times, which means we lost $1 52 times. So you could take that 48, which is a positive number, and minus 52, which is a negative number. That's how much money we lost. So we won $48, we lost $52, and that gives you -4. And if you put it in the context of this problem, after 100 games of blackjack, we would expect to lose $4. This is another good life lesson that generally gambling is a bad idea, especially if you go to Vegas. The odds are stacked against you, and it's almost guaranteed that you'll lose money. All right, now let's ask an investment question. Over 2 years, my investment grew from $100,000 to $125,000. What is the compound annual interest on that? Well, again, we've done a lot of compound interest problems, but this time we're going to do it in reverse. So let's just look back to question number 3, which had all the same components. 1.2 raised to the 10th times 760 gives us 4,760. And let's kind of think about what each of those numbers means. 1.2 is the rate. Remember, the rate was 20%, so here it's 1 plus the rate, 1.2. 10 is the number of years we have. 760 is what we started with, and 4760 is what we ended with. Now let's take all those numbers and substitute it for what is in this question. So we know we have our rate. We don't know what that is, so that's going to be our variable. We know we invested for 2 years, so that becomes a 2. We know we started with $100,000, and we know we ended with $125,000. This actually becomes a pretty simple algebra question where we have an unknown, our rate. So let's solve it. The first thing we're going to do is we're going to divide both sides by 100,000, and that gives us our rate squared equals 1.25. We can take the square root of both sides, and that gives us a rate equal to 1.118, which means that our annual return was 11.8%. Some of you might have gotten 12.5% by doing simple averages, and that's okay, but remember, we were asking for compounded annual returns. This will be very important, so you always want to do compounded annual returns, which means you use those exponents, like a 2, or the x to the y button. Question number 6. A cancer drug kills 30% of the cancer cells each month. What percentage of the cancer cells would still survive at the end of a year? So the first thing we need to do is we need to figure out what number we want to use. Remember, if the drug kills 30% of the cells, that means 70% of the cells survive. Since the question is asking how many cells still survive, we want to use the 70% instead of the 30%. This is going to be really important. So after 1 month, we have the 100% of the cancer cells we started with, and we multiply that by 70%, and that gives us 70% of the cells survive after 1 month, which is the same as 0.7 raised to the first power. After the second month, we take the 70% that survived the first month, multiply that by 70%, and we get 49% survive after 2 months. So 0.7 raised to the second power. After the third month, we take the 49% that survive after the second month and multiply that by 70%, and we get 34% survived after 3 months, which is the same as 0.7 raised to the third power. And hopefully you see a pattern. After 1 month, it's 0.7 raised to the first. After 2 months, it's 0.7 raised to the second. After 3 months, it's 0.7 raised to the third. And we can do this on and on. We can do it 12 times. But as you would expect, this is a compounding problem. We can use that special button on your calculator that does the exact same thing, the x to the y. And you can do 0.7 x to the y 12, which is the same as saying 0.7 times itself 12 times. And if you do that, you get 1.38%. So in this problem, that cancer drug that kills 30% of the cancer cells each month would leave 1.38% of the cancer cells surviving after a year. Great job, everyone. Again, these tests are not easy, and just by virtue of you taking the test shows that you are an awesome stud at math. If you got some of the questions right, that means all the better. Congratulations again, and we're looking forward to seeing you guys after the winter break on January 17th at Summerfield Elementary School at 3:15.